Hello everyone. Today I will be speaking on a topic that lies at the heart of cloud security, identity and access management, or IAM in cloud environments. As organizations continue to migrate to the cloud, protecting data, applications and resources has become a top priority. And at the center of this protection stands IAM, which acts as the digital gatekeeper. Let us begin with a simple question: who can access what and under what conditions? That is exactly what IAM answers. Identity and access management is a framework of policies, technologies, and processes that ensures the right individuals and services have the appropriate access to resources. In traditional on premise environments, access control was relatively simpler, bound within the physical perimeter of the company's data center. But in the cloud, things are more complex. This multiple cloud services, APIs, and third party applications add layers of complexity. This is why IAM is considered the first line of defense in cloud security. There are three main reasons why IAM is so important in the cloud. Number one, security of sensitive data. Number two, regulatory compliance. Number three, operational efficiency. To understand IAM better, let us look at its core components. Identity management. This involves creating, managing, and deleting digital identities for users, groups, and services. In cloud IAM, identities can represent humans, applications, or even devices. Authentication. This is the process of verifying a user's identity, typically through usernames and passwords. In modern IAM, authentication extends to stronger methods like multi factor authentication, biometrics, or single sign on. Authorization. Once a user is authenticated, authorization decides what actions they can perform. Platforms use role based access control or attribute based access control to manage permissions. Access policies. IAM relies heavily on policies that define who can do what. For example, in AWS, an IAM policy might allow a user to read data from an S3 bucket but not delete it. Auditing and monitoring. Lastly, IAM involves monitoring user activities, generating logs, and detecting anomalies to ensure no misuse of privileges occur. Let's look at how IAM works in major cloud providers. AWS IAM. Amazon Web Services offers fine-grained access control. Users and roles are created and permissions are attached using JSON-based policies. AWS also supports temporary credentials through Security Token Service. Azure Active Directory. In Microsoft Azure, IAM is largely handled through Azure AD. It provides single sign on, multi factor authentication, and conditional access policies to secure applications and resources. Google Cloud IAM. Google Cloud offers IAM with predefined roles, custom roles, and service accounts. Permissions are granted at the project, folder, or organization level, giving flexible control. Despite its importance, implementing IAM in cloud environments comes with challenges. Number one, complexity in multi cloud environments. Number two, privilege creep. Number three, insider threats. And number four, balancing security with usability. To address these challenges, let us explore some best practices for cloud IAM. Principle of least privilege. Always grant users the minimum level of access required for their job. This limits damage if an account is compromised. Enable multi factor authentication. Passwords alone are not enough. Adding a second factor, such as a one time code or biometric check, greatly reduces the risk of account compromise. Number three, use role based access control. Instead of assigning permissions directly to users, assign them to roles. For example, an analyst role might have read only permissions, while an admin role has broader rights. Number four, implement identity federation and single sign. This reduces password fatigue and allows users to authenticate once and access multiple systems securely. Number six, regularly audit and rotate credentials. Access logs should be monitored, old accounts removed, and keys or passwords rotated frequently to reduce risks. Number six, zero trust approach. Adopt a mindset of never trust, always verify. Every access request should be validated, regardless of whether it comes from inside or outside the network. Looking ahead, IAM is evolving rapidly. The future trends include passwordless authentication by using biometrics, smart cards, or cryptographic keys to replace traditional passwords. AI driven access control, machine learning models that can detect abnormal behavior and adjust access rights dynamically. Decentralized identities, empowering individuals to control their own digital identities using blockchain based solutions. As cloud adoption continues to grow, IAM will remain a cornerstone of cybersecurity strategies. To summarize, identity and access management in cloud environments is not just a technical requirement, but a business enabler. It protects sensitive information, ensures compliance, and improves efficiency. By following best practices like least privilege, multi factor authentication, and continuous monitoring, organizations can build strong defenses against modern cyber threats. In the cloud, your network perimeter is no longer defined by firewalls, but by identities. And IAM ensures those identities are protected. So until we meet next time, stay safe.